focus on 5G elements because this will be 5G enabled corridor, and the layer of electromobility is another thing that we consider here. In terms of implementation, there is an inference engine that we are about to implement, which would give out as a result, let's say, taken as an input, sorry, the modeling work, that the result will be, the output will be the proposal of certain countermeasures for this corridor. So this is pretty much the scope of each project. I will give you some pointers here and there as I will go through my slides. Basics in terms of risk analysis, I'm pretty much suppose things that are all of you are quite familiar. There are certain concepts, certain ideas in a circle of risk, and even though it is a circle, I would say that there is somehow a starting point, which would be the assets. You first need to identify what is critical, what is important, what is valuable for you. So we call them assets. And then there are threats on those assets that are orchestrated by attacks, actually, that seek to exploit, you know, some weaknesses, some vulnerable points of view. And then all of these ideas and all these concepts pretty much shape what we call a risk. So risk might be a function of those three entities, A, D, and V, or a product, as according to Etsy. But in general, it's a function that say the risk is shaped by a function that accounts for those three parameters. So if you have a risk analysis, what is the main benefit that you get, or how do you tend to exploit that? So in a nutshell, the implications of what is benefit for me is that I can include already in my system design and my implementation, I can include some privacy, security objectives that I have already identified. So some statements describing what do I need and what is the objective of my system, and this is important to know it already. I will give you some examples later on that. And the second thing has to do with what they call impact assessment. I mean, it's the idea of what should I do? How should I mitigate those attacks that I have identified, or those are threats and the vulnerabilities, etc. Is it worth to spend 1,000 euros or 10,000 euros on my infrastructure in order to mitigate any of those risks? So these analyses give you the opportunity to have some informed decisions on this question. Now, you can recognize three basic stages, as we call them here in this slide, and I will give you a few of insights how you might break them down into many other intermediate ones. But in general, you have suppose that you have three main stages. The first one relates to the assets. Is the identification of the assets is a great part of your work, because it's not so trivial to know what is important, because importance might have different meanings and might have different implications on different parts of your organization. You can use, for instance, questionnaires here. Just try to extract the information on what is considered to be, but certain parts of your organization as assets. And the second large stage, let's say, it's the main analysis, the quest for your security objectives, your security requirements, your threats, as I mentioned earlier. And the last one has to do with the impact and the informed decisions that I mentioned before, in terms of what countermeasures should I employ, should I invest on my organization or on my system. Now, moving a little bit into so all those things I mean described, let's say, in those three bullets there on my slide. Moving now a little bit on the work that has been done in SAFERTEC, try to be a little bit more specific. So as I mentioned, there was V2I use cases put under the microscope. So two different large parts. So one is the communication with a roadside unit, a smart traffic light. And the other one is with some cloud-based services. So those are the two large areas of V2I communications. And beneath, we identified a couple of use cases. For instance, the famous Gloss application, or some crossing of a junction and the need to provide priority to a certain vehicle. So different use cases that can lend, let's say, to both instances, either to the communication with a roadside unit or with a cloud. And then the approach in terms of the risk analysis included actually an attractive, let me say, combination of 3 different methodologies that are quite relevant. I will not go into details. You can find actually some of those online, or pretty much you can find quite some information online about them. The difference between them is actually the focus. For instance, PRIS is about the privacy, main things. And the other thing that differentiates them is the origin. So, for instance, eBios comes from French industry, actually. So it's not so academic, but it's actually used in industry for identifying the assets, as I mentioned. And maybe one question here, or one important thing here, is how to bring down all the modeling and the high-level things and what you draw on your paper, or what you identify as objectives and requirements in terms of high level, how you take them down into low-level detail. So what countermeasures should I use in this interface that I have on my system? So this question is not so trivial to answer, and essentially one direction to answer that quite efficiently is to rely on 2 things: to rely on exhaustive and quite detailed and comprehensive analysis, risk analysis, and the other one is try to exploit best practices and standards, and say, okay, I identify that certain interfaces, like the one I mentioned before, typically are covered with this type of encryption, for instance. So you rely on those 2 different parameters to identify this question. But again, this question we will see it again later on, but it's quite important. Now, let me move a little bit. So this is what we did actually in SAFERTEC, breaking down all those 3 different, the 3 main parameters of security and risk analysis that I mentioned earlier. It's essentially broken down into 6 different stages, and this corresponds to quite complicated, to be honest, diagrams where all the entities are plotted and the relations and the dependabilities. I will just be quite short here and brief, try to explain. The first stage relates to the essential assets of your system. Then on the second one, you're looking for resources, the capabilities, and that relate to your organizational structure. The third one has to do with security and privacy constraints that are related to your needs, actually, to your organizational needs. And then there is the attack analysis, and the fifth one, let's say, is the main part of the vulnerability analysis, where you identify those security, privacy objectives. And the last one is actually pretty much what is the typical output of this analysis, some requirements, or just to say it in terms of common criteria that I will mention right after, the so-called SFRs, so security functional requirements. So this is what we did. This was our modeling that combined the 3 methodologies that I mentioned earlier. You can find details in the SAFERTEC webpage if you're interested in this approach. Just one note about the other project and what are the challenges in the other setting in terms of risk analysis. The other setting is quite important, quite challenging, because you do have your vehicle pretty much in the center of 2 worlds, because you are talking about some cross-border use cases in the corridor. So there are essentially 2 different worlds, 2 different settings. So one on the one side of the one country and the other in the other country. So you might have different infrastructure, different services, different providers. And the second one that is quite important here is the dimension of electromobility. So this again adds, let's say, an extra layer of complexity in your risk analysis. And I do have 2 also requirements there, apart from the typical ones: confidentiality, integrity, availability, as you see, that are, of course, are already important in terms of connected vehicles and automation. But maybe here is a little bit even more important: anonymity and also the unlinkability. Now, this work is on progress, so I will not give you, or I cannot give you actually many details rather than the challenges that are appeared here. And with this slide, I would like to move a little bit to the second part, which is the security assurance, as I mentioned, and it's quite important and interesting, even though it's underexplored as far as I know, as far as I see. So what is security assurance actually? What's the problem statement? So it's a question that comes typically, let me say, after the period that I have designed and I have implemented my project. And I say, okay, do I trust that this system satisfied the behavior that it intends to? Or let's say, in other words, what's the degree of confidence that the security requirements are satisfied? So, so according to three different parameters, so three different dimensions, or three different questions you see on the right, according to this, to the answers of those questions, the way to address the security assurance problem, the security assurance evaluation, emerges. And I will give you I will clarify myself just in the following slide. So I mean, what is to be evaluated? So you need to have a clear understanding and a clear description. What are the activities, and who is in charge of that? Who is responsible for that? Now, security assurance might have some relevance to actually to testing, software testing. For instance, if you have a product and someone tells you that this product that you are about to buy, let's say, has been tested 3 times, while some other one, a similar one, has been tested, I don't know, 33 times, then you just might be tempted to choose the second one. And why is that? Because it seems that you trust mostly. Your trust is mostly focused on the extent that has been tested, the extent of the number of tests. So in that sense, security assurance is all about trust. This is the parallel line to the software testing. And discussing about the trust and the different, let's say, extremes. So you see assurance from 0 to 100, and if I do nothing on my product, then I have no assurance that this is gonna fulfill the security requirements. On the other extreme, there are formal proofs. There are rigorous mathematical tools that, in certain cases, may prove to me that the system will work. Or, for instance, no attack, for instance, will cause a system to behave under a certain class. Of course, when we have complex systems like connected vehicles, obtaining formal proofs is very difficult, right? Now, as it is quite relevant in all such cases, the question is what happens in the between the two extreme values, and this is what happens. Essentially, it's a trade-off between efficiency and cost, and I will try to elaborate a little bit on this. Essentially, there are approaches that are of low efficiency, and in this area, efficiency is actually shaped by the level of assurance that I gain. 2 of those approaches are uploaded here, are shown here, and there is another one, the standard that I mentioned already, the common criteria, which is the one with the highest, well, up to the highest assurance level. So vulnerability tests, I suppose that you're pretty much familiar with that. Essentially, the issue here, okay, I can run my test. I can give certain testers the choice to run any test that they want under a predefined period. It depends on the expertise of those testers, and of course, it's difficult to do comparisons. The conformity checks or conformity lists, I have a list of open requirements on my system, and try to check, consider that as a checkbox so that I check if my system meets any of my requirements presented in each line. The difficult part here is to keep it up to date. It's not so straightforward. If I update my system, or if I add the one feature on my system, on my product, what will happen in this list? What will happen in these checks? And of course, anything that is not mentioned in this list, I do not know anything about it. So The most complete, the most recognized approach is the category that is called security assurance framework. Sorry. The most recognized one is this ISO standard. However, there are a couple of more smaller or bigger, let me say, attempts. SAFERTEC is one of them. What's the difference here? The difference compared to the previous ones, apart from the level of assurance that I mentioned and the efficiency, as I mentioned, is the fact that here, as opposed to the previous ones that were executed, actually, all the testing and the evaluation were executed by the same person who pretty much developed it, or the same organization that made the product, that developed it. In that case here, we do not have the same organization. We hire someone else. We say we assign to someone else this procedure. So essentially, this is what we do. We get someone else to do the job and just leave me alone. But this leave me alone essentially has a quite large impact on the cost, because I need to inform this evaluator about my system. I need to detail my system very much so he can understand what my system does. He can understand what my objective is, because essentially in many evaluations, they see that even the developers themselves who have built the system, they do not know the actual objectives of the system or the security objectives of the system. So in that terms, it's quite exhaustive and it's quite costly. This is what SAFERTEC try to do, try to enhance it in certain directions so they can reduce, let's say, the costs in terms of money and time, which is, of course, quite hard to prove it. But anyhow, this was the target. Now, moving a little bit fast on some terminology in terms of common criteria, which is actually it has received quite some critique, but it's the most, let's say, recognized one. Protection profile and security targets, as well as assurance levels, are the most important, let's say, keywords here. Assurance level relates, of course, it's the level of the assurance I get, and it relates to the depth of each evaluation process that the standard suggests to carry out. So according to the depth and the analysis that I undertake, then the corresponding EAL level is achieved. The protection profile and the security target. So protection profile should be quite interesting and should be quite familiar to most of you, or to all of you. It's quite important term, and quite some work has been done lately in different areas. So the protection profile is pretty much like risk analysis, as I mentioned earlier, but let's say put it of course, in a structured way. There is the standards defines exactly the way to build it, and it's quite generic, high level. And I will just give you an example of what do I mean high level. And when you move from the protection profile to the security target, you essentially try to move from this high level description to the detailed one. And just I will give you in 2 slides this notion. So essentially, this is a protection profile table of content. So you can see it's pretty much like a security analysis, like a risk analysis. You need to identify the threats. You need to have some assumptions. You need to identify the assets, the objectives, and finally some requirements, which is, let's say, the output of that. The important thing here is that it's systematic and it's quite structured. And the main target is not to allow you to break any dependabilities or try to miss anything. So just to give you an example, suppose I do have my protection profile from my window, So I want my window to protect me from someone breaking into my house. And then I want also my window to protect my privacy. So those are 2 essentially security objectives, because I have identified that there's the threats that someone breaks in and someone sees from outside inside. And the security objectives are those high-level statements that I want my window to protect me against theft or break, and I want my window to protect me against to protect my privacy. So given those security objectives, I need to identify, let's say, the security, the SFRs, the security functional requirements. This means that one SFR regarding the objective of theft, of non except having someone to break into my house, is I want to have a window of that of that dimension and that type of glass and that type of material. So this is high level, and this is my protection profile. This is the SFR for my protection profile. Now, if I just leave it like that, it's not correct because I haven't covered the other threat, which is my privacy threat, my privacy objective. So in that terms, in that SFR, my corresponding SFR would be, I need to have some sort of a shutter or some sort of a curtain, so no one can see from outside to inside. So I just want to. It's quite a structured document that does not leave any dependencies pending. And then, if you move from this generic description of I want to have a window of that material going exact material that you want and the exact thickness of then you move from the high-level protection profile to the security target. So using those lines that are already prescribed in my standard, the ones that are you see in the top of my slide, those are from a certain class, the cryptographic operation. There are many of them. There are 600 pages of the standard. There are pretty much every cybersecurity has been covered, and there are certain statements like the one you see for each of the open, let's say, cybersecurity issues. Then you take those and you build the corresponding protection profile as the one I have written here. If you go down into detail and describe, for instance, what type of encryption algorithm and what type of key, then you move to the security target. So I suppose that I have a little bit going into many details. I will just give you 2 more slides and I will close my talk. This is what the one contribution of the modular protection profile. This means that you break down actually the functionality of the system into modules, and you build essentially one protection profile for each of those. So there's a base one, which essentially controls all the ITS application databases and everything you have in the vehicle. And then you have the module, the protection profile module that can constitute, for instance, just one sensor or the HMI or anything that you have on your vehicle. And the protection profile configuration is pretty much when you put together one base and the base protection profile and one module. So this gives you quite some advantages. For instance, there is an HSM, the hardware security module protection profile already delivered and compiled. So you can take that and you can, let's say, plug and play into this modular protection profile, and you can use it, you can reuse it actually for your own purposes. You can find this work in terms of modular PPs over the SAFERTEC webpage. And then a couple of slides here. I will not go into details. Those are the different classes that prescribe the different evaluation tasks that you need to carry out in common criteria evaluation. And the process you see in the bottom essentially is an iterative one. And you typically get a success as an outcome after numerous iterations where you identify vulnerabilities. And in certain cases, okay, it's inclusive if you for some reason you lack some details. So there are different classes that described in the standard that you can ask you to carry out certain evaluation tasks that cover, for instance, the life cycle, the maintenance actually of your product, the architecture. You need to identify how your product works, and this is evaluated actually by the evaluator. How you're going to test it or how you have tested it, etc., etc. The last one is about the contributions of this project that I have already mentioned. There is one contribution in the standard that I also mentioned before on the HCTV array. This was something that had to do with privacy issues and unlinkability between the pseudonym that is used in the TV array and some location data. This has to do with the ETSI trust model. And also the toolkit that we have developed has to do with a way to, let's say, make it a little bit more easy to execute all these different evaluation tasks that the standard prescribes. So just to close it, because I'm quite long already, two important dimensions, just as take-home results, take-home remarks. The first one is the risk analysis, and the second one is security assurance. So both of them are quite important, especially in view of the ever-increasing complexity of the systems and the connected vehicles, of course. And both of them, if it's quite effective, can lead essentially to the increase of your trust and increase of the market penetration of the connected vehicles. So thank you very much for your attention, and thank you for the invitation and the great honor to have me here.